talked about the introduction to the cloud computing, and right now I'm going to start with the key technologies in cloud computing itself. So whatever I will be discussing, that is going to be in very detail afterwards also. Not right now. It's going to be an overview right away. But yes, further I will be discussing these things in very detail according to the requirement. And what stuff I'm going to discuss right away, that I'm going to show you. So virtualization and containers, then cloud storage and database management, then serverless computing and edge computing. This is the stuff what I'm going to discuss right away with you. So simply the virtualization and container when we talk about. So there comes the concept of VM, that is the virtual machines and the hypervisors. So like when we talk about the virtual machines, so a virtual machine, that is a VM, is an emulation of a physical computer that runs the operating system and applications on the top of hypervisor. A hypervisor, what is it? A hypervisor is a software program that creates and run virtual machines. Hypervisor itself is used to run the virtual machines on a single physical computer, and it is also known as the machine monitor (VMM). Like the hypervisor, I'm telling you, allocates resources like memory and processing power from the host computer to the VMs, and each VM virtual machine acts as a complete computer itself with its own operating system and program. So virtual machine, what is that? A virtual machine is an emulation of a physical computer that runs on the operating system and applications on like top of the hypervisor. When we talk about the hypervisors, they are the software that creates and manages virtual machines by allocating resources from the host machine. So hypervisor basically allocates the resources to the virtual machines. And there are two different options, two different types, you can say, type 1, type 2. Type 1 is bare metal hypervisors, and type 2 is hosted hypervisors. So when we talk about the bare metal hypervisor, that is the type 1. So they run directly on hardware. For example, VMware, ESXi, and Microsoft Hyper-V. These are in the type 1 category. You can say bare metal hypervisors. And the type 2 are like hosted hypervisors. They run on an operating system like a virtual box or VMware or workstation itself. Then when we talk about container versus virtual machine, so there comes a concept of Docker and Kubernetes. Although I'm not discussing Kubernetes or Dockers here, but yes, Docker, Kubernetes, as an example, I will be using. So when we talk about the container, so containers are basically lightweight. They are lightweighted, standalone, and portable software packages that include the applications and its dependencies, but share the host kernel. So host operating system kernel is shared when we talk about the container. They are lightweight, standalone, and portable packages, but its dependencies are like on the shared host kernel. When we talk about Docker, a popular containerization platform it is that enables developers to package and deploy applications efficiently. Okay, efficiently. So simply Docker is an example of container, you can say. And Kubernetes, like it is orchestration tool that automates container deployment, scaling, and management across multiple nodes. So simply you can say Kubernetes is further like working, you can say, after the Docker it's required, you can say, for the deployment purposes, for scaling and managing the applications on multiple nodes throughout the network. Okay. In a distributed network, you can say it will be working. And when we talk about cloud computing, in the cloud computing, anyways, the distributed networking architecture is there, definitely, because we are able to access the things from anywhere, anytime. Okay. Now, simply let's talk about their features. So simply the features which we are going to talk about, that is going to be the OS overhead, speed, resource usage, and scalability. So on these four features, I will be comparing the virtual machines and the containers. So when we talk about the OS overhead, so virtual machines require a full operating system per virtual machine. Full operating system per virtual machine is required. Whereas in the containers, shared host operating system kernels are there. When we talk about the speed, virtual machine, slower boot time, Okay, the boot up time is slower as compared to the container, because containers are faster at the startup. Then the resource usage, if we talk about, so virtual machines like more resource intensive, and when we talk about the container, lightweighted. Containers are lightweighted, containers are fast, containers are having the shared host operating system. That is the reason why they are fast and lightweighted. Then when we talk about the scalability, so in the virtual machine, it is harder to scale dynamically, whereas in the container, it is easier to scale and deploy. So you can just take a look at it, the comparison. After that, let's talk about the cloud storage and database management. That is going to be the second topic in this particular. So when we talk about the cloud storage and database management, so although this is going to be in very, very detail, because the DBMS, some are like advanced DBMS features also we will be discussing. Storage preferences also we will be discussing further. Even the AWS will be in the complete detailed manner. So when we talk about the cloud storage and database management, so storage types in the cloud are object storage, block storage, file storage. Okay, so and SQL and no SQL. So simply that I will talk about later. Before that, I will talk about the object storage, block storage, and file storage. So when we talk about AWS S3, this is actually something inside, you can say, AWS. Like simply the what is AWS? AWS is Amazon Web Services. There we are having the concept of S3. So the S3 is what? It is like object storage. Okay, it stores data as objects with metadata and unique identifiers, and used for large scale unstructured data like images and videos. When we talk about the block storage, so EBS, okay, EBS is again there in the AWS. So it provides low latency, high performance storage, like similar to the hard drives, and it is ideal for databases and applications requiring fast read write speeds. So block storage is for that, low latency, high performance. Okay, then when we talk about the file storage, so it is managed by, you can say, like managed file system like Amazon EFS, Google Cloud File Storage, and Azure File Support, access, shared access it is having the file storage with file hierarchy structure. So hierarchical structure, top bottom approach kind of is there when we talk about the file storage system. So these are the different storage types in the cloud. After that, SQL and NoSQL is there. So SQL is simply the relational database management. You can say RDBMS concept is there. So simply like if you must have heard about the like MySQL and all, that is concept of SQL. Oracle is also giving the concept of SQL. When you talk about NoSQL in the, you can say, normal scenarios in the without cloud, when you are working that time, simply as MySQL, Oracle kind of stuff you can use for the SQL. For the NoSQL, MongoDB is there. Okay. So when we talk about SQL, that is the structured query language, which is actually present in the relational database management, which is known as RDBMS. So structured data with flexible schemas. Schemas are the tables, database tables. Asset compliance, asset properties are there. Okay. So simply, for example, in the case of the cloud, Amazon RDS and Google Cloud SQL is present for the RDBMS, you can say, relational database management system. Okay. Then NoSQL, when we talk about, so non-relational databases are there, and it is having the flexible schema for semi-structured or unstructured data, great for big data. Okay, a huge amount of data you are having. So MongoDB, Atlas can be used, DynamoDB can be used. Okay, and I will be telling all about it. Then simply, if we compare and contrast the SQL and NoSQL, because it is quite interesting and important anyhow. So simply, when we talk about the features, so schema, transaction, scalability, and use cases, I will be comparing. In the SQL, which is known as the relational, the schema is fixed. The rows, tables you define directly. In the non-relational, NoSQL, it is flexible. It is a document-based architecture actually. JSON like concept is there. JSON concept is there in the NoSQL. Then simply the transactions are having the strong asset compliance in the SQL, whereas in the NoSQL it is eventual and consistency is there. Eventual consistency is there. Then when we talk about the scalability, so vertical, the SQL is vertical. Okay, simply scale up. When we talk about NoSQL, it is horizontal. It scales out. Okay, these are the like terminologies you can say. When we talk about the use cases, so for the SQL, like banking, ERP, CRM, that is the content management system, sorry, customer relationship management, CRM. And for the NoSQL, social media, IoT, big data, the MongoDB and all is getting used there. So simply the social media, IoT, big data is example, the use cases of the NoSQL. Then the next thing which comes into the picture, that is going to be the serverless computing and edge computing. Serverless computing and edge computing, very, very important stuff, very important concept which I am discussing with you. So simply when we talk about the serverless computing, how serverless computing eliminates infrastructure management. That is the thing which comes into the picture. That why to use serverless when we are already having servers? So what is the meaning of serverless? What is the serverless computing? How serverless computing eliminates infrastructure management? When we talk about this, serverless computing allows developers to deploy applications without managing servers or infrastructure. When we talk about serverless, so you do not have to simply deploy. Okay, it is serverless actually, serverless. The cloud provider automatically handle scaling, resource allocation, and maintenance. Serverless computing is a cloud-based model for building and running application without managing servers. You don't have to manage the servers. And in this model, a cloud service provider, that is also known as the CSP, manages the infrastructure. So developers can focus on writing code. Like you can say how it works. Developers write and deploy code to the cloud. The CSP, that is the cloud service provider, provisions, scales, and maintains the infrastructure. And developers pay for the resources they use, not for the servers themselves. And when we talk about the benefits of the serverless computing, you can say, so it is cost effective, scalable, flexible. Okay. And if we talk about the use cases of the serverless computing, so simply RESTful APIs, microservice support, high volume background processes, and backend task for mobile apps and websites is serverless actually. IoT data processing is serverless. Event triggered computing is serverless. So, so simply AWS Lambda is an example. AWS Lambda, an event-driven serverless computing platform, it is for from the Amazon Web Services. So AWS Lambda runs functions in response to triggers. For example, HTTP, that is the hypertext transfer protocol request, database changes. For that is there, it is there. Google Cloud Functions, like similar to the Lambda, there is like Google Cloud Functions. It like used for event-driven applications. There is one Amplify framework also, an open source framework for building cloud-enabled mobile and web application. Amplify framework is the name there. Then when we talk about the edge computing, okay, like we have talked about the serverless. Now, if I talk about the edge computing, it is really very buzz term, you can say. So in the edge computing, the cloud computing is there. So cloud computing and edge computing are the two terms. Edge computing is basically a technology that processes and stores data close to the users or devices that you can say generates it. Okay, who is generating it to them, near to them, it is stored instead of a remote data centers. Like in edge computing, simply you can say it is the technology that processes the data close to the user or the device, and it's useful for the situations that require real-time data processing analysis. Okay, when we talk about cloud computing, it processes the data in centralized data centers suitable for large scale applications. Whereas when we talk about the edge computing, it processes the data closer to the user or device. For example, IoT devices, smart sensors, to reduce latency. So here you can see the comparative study of cloud computing and edge computing. The features which we are comparing are processing location, latency, and use case. When you talk about the processing location, so in the cloud computing, it is centralized. Data centers are there, central data centers are there, you can say. In the edge computing, distributed near the data source. Okay, in the edge computing. Then when we talk about the latency in the cloud computing, it is high. When we talk about the edge computing, so it is low. Latency is low. So latency, what is latency actually? Latency is the delay. Okay, latency is the delay between when an action is performed and when it reached to its destination. Okay, when some action has taken place and when it reached to its destination, between them, whatever time is getting taken. So simply that is the delay. It is known as the latency. It is simply a networking term. I hope you are already knowing it. Then when we talk about the use cases, so use cases are simply the web apps, SaaS platform, simply the software as a service models I have talked about with you. In the edge computing, the use case could be the IoT, autonomous vehicles, because there also the real time data is required when we talk about the autonomous vehicles. Okay, so this is a brief comparative study of the cloud computing and edge computing. So I hope whatever I've discussed till now, that much is clear to you. In case you have any query, you can tell.